What's up, Raiders? In this short video, we're going to analyze a basic cliff scenario, what I'm going to call level 1, the most basic scenario, where instead of being thrown upward or downward with a specific velocity, or instead of being thrown at an angle, a ball is just dropped from a cliff. So let's say that we have a cliff that's 50 meters high, and you drop a ball down. Now, there's a variety of questions you can ask about a scenario like this, but we're just going to focus on if the question had been, how much time will it take for the ball to hit the water? How much time will it take for the ball to hit the water? So again, this is what we're calling a level 1 cliff problem, and level 1 meaning the ball is just dropped. It's not thrown with a specific velocity or thrown at an angle or anything. So the first thing to do in applying our problem-solving technique, identify what information is given to us or that we know in terms of our equation variables. So information that's given to us. We know that the ball's initial velocity is going to be 0 meters per second. And notice I specified initial velocity here. That's implying the fact that the velocity will be changing over time due to the acceleration of gravity. If you just put plain old v for velocity equals 0, you're basically making the statement that the velocity would stay constant in this situation, which is not true. Speaking of that, we know the ball is going to experience an acceleration due to the downward pull of gravity, where it's going to speed up 9.8 meters per second, or 9.8 meters per second squared, but acceleration is a vector quantity, direction matters, so we put in a negative sign to show that gravity is pulling downward on it. And sticking with the theme of vectors where direction matters, the ball's displacement. A lot of times the natural tendency might be to say, oh, the ball is 50 meters up, so let me say displacement is 50 meters. But displacement is where something ends up compared to where it started. So since the ball ends up 50 meters below where it starts, the displacement is going to be negative 50 meters. So these are the three variables we know. And what we're trying to find in this particular scenario is t, time. How much time is the ball in the air if you just drop it from a height of 50 meters and gravity pulls it down, accelerating at 9.8 meters per second, or 9.8 meters per second squared. So the next step then is to look at your equations and figure out which equation ties together this specific combination of variables. In this case, we have the quadratic d equals vit plus 1/2 at squared. Substitute in the values that you just identified. So we know the displacement, again, it ends up 50 meters below where it starts, it's negative 50, equals, now the initial velocity is 0 because the ball is dropped, so this term goes to 0. So negative 50 equals 0 plus 1/2 times negative 9.8 t squared. So we'll simplify this a bit here. So we're gonna have negative 50 equals, and 1/2 times negative 9.8 is negative 4.9 t squared. We want to figure out t. So in our efforts to isolate that variable, divide both sides by negative 4.9. So we're going to have t squared is approximately equal to 10.20. So take the square root of both sides. And t, the time to hit the water, is approximately 3.19 seconds. Okay, in another video, we'll take a look at a slightly more complicated scenario where instead of the ball just being dropped, it's actually thrown upward or thrown downward with some velocity. As always, if you have any questions, contact me.